Hi, I'm Professor Goins. Welcome to the Math Professor's YouTube channel. If you're looking for videos explaining topics in pretty much any college mathematics course, please consider subscribing to our channel and then checking out our playlists, watching videos, liking, commenting, sharing those videos. Those are really simple interactions that you can do that any and all would be greatly appreciated because it does help us out with the YouTube algorithm to reach more of an audience. Let's get into the current video. I want to take a look at what's called the square root property. And this is something that you'll see when you start looking at solving quadratic equations. So here's the idea. If I have the equation u squared equals d, where u is equal to u of x, meaning an expression in x, and d is greater than or equal to 0, then we can say the following. Quick side comment, if d was negative, then we would come up with complex solutions. And we'll talk, actually, you know what, here, let's do it this way. Let's include that case. Let's say d is just a real number. So let's include all three cases. If d is a real number, then the value of u, which again is an expression that involves x, could be x plus 1, could be 2x, could be 3x minus 4, something like that, but it's an expression in x, then u is either the negative square root of d, or u is equal to the square root of d. And we can clean up that notation a little bit depending on the exercise. We can write this as u is plus or minus the square root of d. So that stacked plus or minus means the positive or the negative or the positive. So we can either separate it into two separate equations, or we can leave it in one equation with the plus or minus in front. Okay. Now, if d is positive, then there's two real solutions. Let me, again, I always make side comments. Let me go ahead and make an aside comment that I'm going to assume that u is an expression of x, but u is linear. Therefore, in this case, there would be two specific real solutions. So let's say that u is linear. Now, of course, in your pre-calculus course, calc course, so on and so forth, u could be any expression that has like trig functions or logarithms or radicals or anything like that. But for right now, I'm saying I'm assuming that this is, if you're watching this, you're in a beginning algebra, intermediate algebra, perhaps the beginning of a pre-calc course, where u would be like x plus 1 or x minus 3. And you'll see throughout the solutions what that looks like. If d is positive, then there's going to be two real solutions. If d is equal to 0, then there's going to be one real solution. And if d is negative, then there are two complex solutions. Okay. So let's see what these examples look like. For example, let's say I give you 2x squared is equal to 24. Okay, so 2x squared is equal to 24. Well, this is pretty similar to that expression. However, the squared term, I need to have the squared term by itself, which means I have to get rid of this 2. Therefore, I will divide both sides by 2, giving me x squared is equal to 12. And now this is in the correct form, where it's u squared equals d. U in this case would be x, d in this case would be 12. What the square root property says is when I have this, the value of x is going to be either plus or minus the square root of 12. So notice three things happened going from this step to this step. The square went away. I put a plus or a minus, and then I did a square root. So three things happen. The square goes away, and then on the other side, I put a square root over the 12, and then in front of that, I put a plus or a minus. Okay. Well, 12 is not a perfect square, but notice I can actually factor 12 a couple different ways. One, I could do it as 2 and 6. I could also do it as 4 and 3. Well, when I do it as 4 and 3, notice that 4 is a perfect square. And using the product rule for radicals, I would have the square root of 4 times the square root of 3, which would be plus or minus 2 root 3, and that would give me the value of x. Okay, so x would be plus or minus 2 root 3. All right, now if you are taking an algebra class and you were to provide this as an answer, the plus or minus root 12, it's correct, it's just not simplified enough. Your instructor would probably want that to be reduced. Chances are your directions will say solve and simplify as much as possible, so this plus or minus 2 root 3 is the answer that you would want. If you're using some sort of a computer management system like MyLab, chances are it would want this as your answer as opposed to plus or minus root 12. Even though they are both equal, it would want you to reduce it as much as possible. All right, let's look at another couple of examples. Let's say I give you negative x minus 1 squared plus 16 equals 0. All right. Well, once again, I want to manipulate this so I can get it in the correct form. I can start by subtracting 16 from both sides. I could divide by negative 1. And now I do have it in the appropriate form, where in this case u would be x minus 1, and then d would be positive 16. All right, square root property then says x minus 1, so that'd be the base on the left side. The base where I get rid of the square is equal to, I put a plus or a minus, and then I do the square root of the value d. So plus or minus root 16. All right, then let me go ahead and there's a couple of steps. I'll just put them right here. I can add 1 to the other side. X is equal to 1 plus or minus the square root of 16. Now, of course, 16 is a perfect square. Therefore, the square root of 16 would be 4. 1 plus or minus 4. And remember that what this represents, over here I didn't have to do it. I just left this plus or minus because these were, I couldn't combine the values, whereas down here, well, I got 0 plus or minus 2 root 3, right? So there's nothing to combine. But down here, I've got 1 plus or minus 4. Therefore, what I'll do is I'll combine these 1 plus 4, which would be 5, and then 1 minus 4, which would be negative 3, and these would be the two solutions for that quadratic equation. Let's look at another couple examples. Let's say I give you 2x plus 1 squared plus, let's say, 27 is equal to 0. Well, you can see that the first couple things I have to get rid of, the 3 in front of the squared term, and then the positive 27. That way I get the squared term isolated. Again, to use the square root property, I have to have the squared term isolated equals a constant. Okay? Subtract 27 from both sides. All right. Divide by 3. And of course, negative 27 is divisible by 3, which gives me a negative 9. Okay? U squared in this case would be 2x plus 1 squared, and then d would be negative 9. And remember on the previous screen what I had down here, if the d value is negative, I'm going to have two complex solutions. Okay? Square root property gives me 2x plus 1 is equal to plus or minus the square root of negative 9. All right. Now, Negatives under square roots, we can only do that after we in an algebra class, after we introduce complex numbers. Prior to that, we would say there's no real solutions, and we would stop here and just say that the solution set is the empty set. However, after we introduce complex numbers, we can go another couple of steps. We say, well, this is actually a thing now, and plus or minus root 9, the square root of negative 9 is plus or minus. Remember, the square root of negative 1 is I. 9 is a perfect square, therefore this reduces to 3i. And the other side again, 2x plus 1. Within that equation, just keep in mind, x is my unknown, it's my variable, and I, even though those are both letters, they represent different things. I is the fixed value off to the side here. Remember, I is equal to the square root of negative 1, and it's referred to as the imaginary unit. All right, isolate x in this case. I'm going to subtract 1. Divide by 2. And I get negative 1/2 plus or minus 3/2 I as my solutions to the quadratic equation. Do one more example. (3x minus 4 squared equals 0). This was the middle case that I had on the original screen, where I had if d was positive, 0, or negative. And remember, in the case where d was 0, I said that there's one real solution. Okay. Well, let's go ahead and use the square root property here. If I've got the square of an expression, x equals a constant, that says that the base of this expression, 3x minus 4, would be plus or minus the square root of the other side. Now remember, the square root of 0 is 0, and then positive 0, negative 0 is the same thing, and therefore this reduces to 3x minus 4 equals 0. Add 4, I get 3x is 4. Divide by 3, I get x is equal to 4/3. And as I said, x is equal to 1, has one real solution. Okay. Now, just real quick, at the very beginning I said let's assume that u was a linear function, and that will be appropriate for the examples that you would see in your beginning algebra, intermediate algebra, college algebra, whatever your course is called, probably a pre-calculus course, maybe a calculus course, but once you start getting into like later into a pre-calc and then calc 1, etc., it could start getting a bit messier. For example, if I had like e to the negative x plus 5 squared is equal to, actually let's make that, let me even change that, because that was still going to give me one real solution. Let's say I do something like sine squared x minus 1/2 squared is equal to 1. Actually, let's make that 1/2, because I had no, make that 1/2. Okay, this is going to give me infinitely many solutions, and again is more than likely beyond the scope of your algebra course. You wouldn't see sine squared until you do trig later in pre-calc or in a trig course. But I'm going to go ahead and wrap it up, so thank you for watching, and please consider subscribing.